Welcome at the Things Conference. Another great guest on the table. Welcome. Who are you and what do you do?
Yeah, thank you. My name is Jan Jongboom. I work as a developer and evangelist at ARM. ARM is a semiconductor company, mostly known from the systems on a chip on mobile phones. But 99% of all smartphones use our systems on a chip. And we're also trying to make waves in the Internet of Things space. And LoRa is one of our primary focus points this year. And that's why I'm here at the Things Network.
So what kind of conductors do you make for LoRa?
So for LoRa, our focus is mostly on the microcontroller, so the brain behind the computer, and especially for LoRa devices that need to run off a battery, power consumption is really important, and that's what we specialize on. And then the second thing is that we have a software stack, and the software stack supports LoRaWAN 1.0.2, and that's something that we're introducing here during the LoRa Alliance meeting that was just preceding the Things Network conference.
And what was new about this?
For us, it's one about size. Internet of Things devices need to be small and need to be cheap. And if you want to make a small and cheap device, you need to use very little die size. So having a compact LoRaWAN stack that's also certified and also comes with a bunch of features like very good low power consumption, latest features, having support of like a proper operating system behind it, support for LoRaWAN Class A, Class C, and in the near future Class B on LoRaWAN 1.1. That's really important, and we think that if we provide with an open source software stack specifically for devices, that will be good for LoRa adoption in general.
You also brought a bit of hardware with you.
Yeah.
What are we looking at?
So we are looking at a Altec Firefly 1705 board. It was a board that we designed half a year ago, specifically for the LoRa Alliance All Members meeting in Philadelphia. It contains a Multitech X-Dot module, which is ST silicon with a SX1272 radio chip, and some external flash. And we created this board because in June, actually in February, ARM, the Things Network, and Semtech started a project to bring firmware updates to LoRaWAN. And for that, we need some external flash next to the radio and the processor. And we figured what better way to demonstrate this to the world is actually create a custom board with our logos on it to celebrate that.
Right, because this is basically the first set where you can actually do an over-the-air update.
Yeah, correct.
And that is important.
I think that's very important. Like for a typical IoT deployment, we see an average lifespan of about 10 years. I mean, it doesn't have to be exactly 10 years, but it's definitely more than 1 year and definitely less than 100 years. But in 10 years, in the typical lifespan of a device, like a lot changes. There's a variety of vulnerabilities that might be found in the networking stacks. Think of the Heartbleed bug that was found in OpenSSL 2 years back, and it was in the stack for 3 years. And if you have a device that is not patchable, it will be open forever and is vulnerable forever, and it's only a matter of time before it's being taken over. And we've seen a bunch of botnets appear in 2017 that took advantage of that. But also requirements change. So maybe LoRaWAN 1.2 adds some really cool geolog features that require a update of the software stack. You're not going to send a technician out to manually update all of those devices. And last, the actual specification and the rules of the game might change. If the European Union today says, well, in 8 years, we're going to restrict the usage of the EU 868 band, and you can only use 0.1% duty cycle on 869.525, then you have to retire all your devices because they're not compliant anymore. You might actually be fined. So a firmware update can mitigate all those three things: vulnerabilities, change of features, and change of specification.
Now you've been working on this particular device that you launched this week, etc. But you obviously have a roadmap for many other cool things. So yeah. What are you working on at ARM for IoT?
Yeah. So within ARM, we see the Internet of Things as something where security is currently a really big problem. We want to bring security to the Internet of Things, but you can only do that if you are in full control of your silicon, if you're in full control of the software stack, and then also in full control of the transportation layer to the cloud. So in our marketing term, they say security from silicon to cloud. So within ARM, we are adding new features to our silicon. So we have added trust zone to our V8M architecture, which allows you to create on a microcontroller, which typically has a flat address space, to create multiple security contexts. So you could say that I'm running my firmware update service, which is a big attack vector, because if someone can control my firmware update service, he can take over my whole device forever, because I can never gain control back. So I'm running it in a separate security domain. And I can only verify, oh, I got a firmware package. Is this actually signed by a trusted party? And then the security domain will say yes or no. And even when my application gets compromised, because maybe I have a buffer overflow or I have some code injection bug, they can never compromise the secure part of my thing. So that's something we need to add in silicon. And then we need an operating system running on the device. It can be a very small operating system. It needs to run in a few kilobytes of RAM to take advantage of that and run a firmware update service is actually secure and can be audited. And then you need a transportation layer, you need asymmetric crypto, because you need some additional cryptography during the communication between the device and the cloud, especially when firmware updates. Because if you don't do an additional security layer on the link when someone sends you an update, let's say the Things network are compromised, and someone can start sending firmware update packets to all your devices, that's terrible as well, and you don't want to put that risk in. So we need an additional layer between the cloud or the LoRa network and the device specifically for firmware updates, and you want to do that through asymmetric crypto. So for that we have a library called mbed TLS, one of the most popular embedded TLS libraries, also open source, that brings those security primitives to these type of devices that can run in very little RAM, and that's generally the focus that we currently have within ARM.
So, and apart from the specific hardware that you see, what kind of applications do you see that are quite interesting, or industries or segments that are developing pretty fast now or are gaining traction?
So one of the coolest things that we realized while we're working on this is that there are whole industries that we have no idea of. I was at the Hannover Messe. It's a very large trade show. I think of more than 100,000 people coming over there, and that's all they call it. They don't call it Internet of Things. They call it Industry 4.0, and it's just about smart factories and smart machines. And in there, I ran into a company that does protective seals for shipping containers. I think they're actually at the Things conference there as well. So typically, you seal a container with plastic or with like a lock, and then whenever the seal gets broken, you know that someone went into the container. But there's a variety of ways of circumventing that. So they made a little small device running ARM mbed, our operating system, with an ARM core in it, that you place inside the container. And then based on luminosity sensors and based on accelerometers, they analyze whether someone actually went to the container during shipment. And one I never thought of this as a problem because I don't know anything about the logistics business, and two, all of a sudden they get information that they never had, because before it was only either the container has been open or the container has been closed, and now they can get our data, like, okay, so what was the temperature of the shipment during the whole trip? And they during one of their initial tests, they saw that it was slowly temperature rising during a shipment of, I think, bananas somewhere in East Africa. And they were looking at it, they were like, is this a faulty sensor or what might be going on? Because the seal was still intact, nothing happened. So they questioned the driver and then realized that he stopped the car on the side of the road to steal some diesel from the tank. And they had to turn the... But this is amazing. You get all this super cool information. I have no idea about it. And I don't know the problems of society in Africa. I don't know the problems of society in Asia. So the only thing we can do is give the technology and see what amazing things people build with it. And I think that actual killer use cases of IoT are going to be use cases that we have no idea of today, but we'll find out in a couple of years.
And it's also important, you learn that it's important to go out there and to go to places that you usually don't go to, because it is also input for creating new devices and new technology.
Yeah, absolutely. Last year I taught at a summer school in Tanzania. So this is, it's called Data Science Africa. ARM is sponsoring it this year again. There was 300 people, PhDs and master students, mostly mathematics, that were focusing on machine learning and data science. And they know the math very well. But one of the things they don't know is, like, how do I build these devices to get the data sets that I need, rather than reusing it? So we went there, and as part of the summer school, we did a 2-day IoT session. And then we asked the students, like, what are the problems that you have that you would like to solve? And let's go into the field and see if we can actually do that. So we went to a dairy farm, and this is in Tanzania. It's just a bunch of cows in a field. And we went talking to the farmer, like what the problems he has. One of his big things was that he wanted to know when a cow was in heat, because the semen samples that they need to buy are very expensive for them, like $2 to $4. So you only want to inject them if you very much know that the cow is actually in heat. And the second thing is that I wanted to see if they could predict when a cow gets sick based on the behavior. So we had sensors on the cow, accelerometers and gyroscopes, and then we tagged the data of what the cow was doing at that point and see if we could cross-reference data from those sensors with what cow was doing and see if it was getting more restless when getting sick. That is beautiful. We can only provide the technology, and then these amazing use cases just appear straight for your eyes, and that really inspires me, yeah.
Well, that's very interesting indeed. And so we're here at the Things conference, and so you have a collaboration with the Things Network. How does it work? How does it?
Yeah, I mean, both ARM and the Things Network are members of the LoRa Alliance. So we've been working mostly on the firmware update service in the last year. But I know Johan and Wienke, the initiators of the Things Network, very well. 3 years ago, when they started exploring the idea of the Things Network, I was working for a telco on a LoRaWAN network stack. So Johan and me had a bunch of conversations back then about like how a network should be built. And I know that I thought that Johan was a bit arrogant because all my suggestions, he basically said, no, I know how to do it better. And back then I thought that was probably a mistake, but here we are, 600 people at his conference and, well, 0 at mine, so.
But are you also cooperating outside the alliance, or is this?
We're trying to focus on like small things. So we try to find projects where we see that the alliance doesn't have a solution at this point, or where it's moving slower than we would have liked. And Things Network is still really a startup, and they can go really fast and explore ideas quickly and iterate on them, and that fits as well. So. Like we do a lot of prototyping, we do a lot of events together because we both, like the segment of people that we try to reach is very similar. So next year I'm hoping that we can do some stuff about security and LoRaWAN, like why is my join key still being sent over, basically over LoRa spectrum, but to join, can I have a secure element that my keys never actually leave my device? How would that look like? How would those keys get into a device in the factory? I would really like to see what we can do there, and the Things Network is a great partner to do that with.
All right. Thank you very much.
No problem. Thanks.
Thank you for watching. It was another great interview with a great guest again at the Things conference. There's many more in this YouTube channel, so watch them all.